Welcome everyone to Algebra 2, Section 6.1, Properties of Polynomial Functions. So first of all, what is a polynomial? And a polynomial is an expression with many terms. So the prefix poly just means many. And then how do you add or subtract polynomials? Well, you add or subtract the like terms. So we have this whole polynomial plus the other polynomial here. And so something I like to do is say, okay, what are my like terms? Well, I have x to the third, x to the third. Remember, like terms have to have the same variables to the same exponents. And I like to underline them. And so I can say, hey, I'm going to put them from the highest exponent down to the lowest exponent in that order. So the highest exponent is coming first. And so I'm going to underline those with one underline. And as I move on to what would come second, I'm going to put two underlines underneath those. And then third, three underlines, and fourth, four underlines. Definitely not something you have to do, but it can be a great way to organize and make sure you're combining what you need to, as well as making sure you're not missing something. So now as I'm combining my one underlines, 2x to the third plus x to the third, which has an invisible 1, is 3x to the third. And I can do a slight cross out there and say, hey, I covered those. Now I have negative 5x squared plus 6x squared. That gives a positive 1x squared, or just x squared. Positive 3x with nothing else is just plus 3x. And then negative 9 plus 11 gives me plus 2. And now nothing else can be combined because they all have different exponents, or no variable like the 2 does. And they're in the descending order from the highest exponent down to the lowest. On 2b, I want to talk about this note. It says, hey, distribute the subtraction sign to everything in the second set of parentheses. What that's saying is, this subtraction sign here, we're doing all of this minus this. So what might happen is if you start doing your underline thing or organizing however, you might say, okay, 8 minus 3, and you get 5. And then you do negative x, but then you might forget to do the subtraction on the second one. So maybe you just do negative x plus 2 and you get 1. Well, that would end up being incorrect. You actually have negative x squared minus 2x squared. So we got to factor in that we're subtracting every single thing that comes in that second parenthesis. So a good way to go about it is to turn this into a plus sign and change all of these signs that follow to the opposite. You don't have to change the previous one, but just the following ones. Because now as we go through and underline and get all of our like terms together and all of that, and we start to combine them, when I'm saying, okay, 8 and a negative 3, we get 5x cubed. And we can say, okay, negative 1x squared and negative 2x squared, negative 3x squared. And it makes the process a lot simpler for us to go through once we already do that work of changing the signs early. So we have negative 5 plus 1 is negative 4x. And 1 minus 7 more is negative 6. And now we have everything combined. Multiplying polynomials, you have to distribute and then add like terms. So you do everything in the first parenthesis times everything in the second. So you do 7x squared times 5x to the fourth. 7 times 5 is 35. And when we multiply with those bases, the x and the x, you add the exponents. So 3 plus 4 gives us x to the 7th. 7x to the third times negative 3x squared is negative 21, or 21, x to the 5th. 7x cubed times 3 is positive 21x to the third. And then we do 6x times 5x to the fourth and get 30x to the 5th. Times negative 3x squared to get negative 18x to the third. And times 3 is positive 18x. Now we need to combine like terms and reorder it like we did in the last one. So we say, okay, highest exponent is x to the 7th, then are the x to the 5ths, then the x to the 3rds, and then just the x. So as we order these, we'd have, okay, 35x to the 7th is by itself. And then negative 21 plus 30 are both x to the fifth, so we get 9x to the fifth. 21 and negative 18 are both x cubes, so we get plus 3x cubed. And then we have the plus 18x. On the next one, we have 3 sets of parentheses. The best way to go about this is to ignore that third parenthesis for a moment. And so I don't actually want you to cross it out or cover it up, but I'm just going to do that on here to kind of showcase what happens. So we're going to multiply these first two together, finish everything we can do there, and then we'll see what happens after that. So you do x times x and get x squared. X times negative 6 get negative 6x. 4 times x is 4x. And 4 times negative 6 is negative 24. And I'm going to combine these to like terms to get x squared minus 2x minus 24 with the negative 6x and the plus 4x combining. Now what we can't forget about is that third parenthesis. So we have to bring it down and bring it down. And now we multiply this parenthesis with this parenthesis together. So you do the first two, wait, and then do the new two that are there. X squared times x is x to the third. X squared times a negative 5 is negative 5x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 5 is positive 10x. Negative 24 times x is negative 24x. And negative 24 times negative 5 is positive 120. Now, as I make sure everything's in the right order, I'm going to go up here. And let me kind of just separate off my work from the previous problem as I underline. Everything's in order, just things need combined. So we have x to the third minus 7x squared minus 14x plus 120. So once again, you do the two of the parentheses. It really could be any two. I just typically do the first two because they're the first two you see left to right. And then pause, and then incorporate that last parenthesis. On letter C, we end up having to do the same thing we did on B, but at first it's kind of disguised because it's x minus 4 cubed. And we might think, oh, okay, we can just call this x cubed minus 4 cubed and do 4 cubed and blah, 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 blah. That won't work. And we'll see why that would end up being wrong here. So because what you have to do is x minus 4 times itself 3 different times, because that's what it means to be cubed. So again, we'd have to use the first two parentheses at a time, and then wait, and then do the last parenthesis. So x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is plus 16. And I'm still going to bring down that last parenthesis. And I could start multiplying now, but it's going to make my life a little bit more complex. So I'm going to combine things first and get x squared minus 8x plus 16. And get x minus 4. Now I'm going to go ahead and distribute. And get x cubed, negative 4x squared, negative 8x squared, positive 32x, plus 16x, minus 64. So now as I combine like terms, I get x cubed minus 12x squared plus 48x minus 64. So that ends up being very different than if we had just done x cubed minus 4 cubed and gotten x cubed minus 64. Factoring out a GCF, we actually practiced this last semester, so that'll be handy that we're going back to it to kind of refresh ourselves, kick some of that rust off. So we say, hey, what do all these have in common? Well, number-wise, they all have a 3 in common. And variable exponent-wise, they all have an x in common. So if we factor out a 3x, we're left with 5x cubed, because 15x to the fourth divided by 3x is 5x cubed, minus x, because negative 3x squared, divided by 3x is negative x, and plus 1. Because if you were now to multiply this back in, you would get what you originally started with. Go and try letter B on your own real quick. All right, here the GCF is just going to be x, and you're left with x minus 5, because they both only have an x in common, no other numbers. All right, now time to go on to the new stuff. That was all review from either this year or previous years. A polynomial function, once again, has many terms where all exponents are positive integers. It's going to be a lot to write on the line. Might want to abbreviate positive. And the coefficients are real. I don't know why that line's so big for real. Meaning there's no imaginary numbers. Remember, I or the square root of negative 1. We won't have that in polynomial functions. And when we say positive integers for the exponents, that means no decimals or fractions. And then they can't be negative as well, obviously. The degree of the polynomial is the largest exponent. And the degree will tell you what type of function you have. So if you have a degree of 0, it's what we call a constant function. An example would be like y equals 21, or some number. A degree of 1 is what we call a linear function. So like y equals 2x plus 3. Degree of 2 is a quadratic. An example would be y equals 3x squared plus 4x minus 8. That's what we just worked on in 6.0. A degree of 4 is a cubic. We haven't worked on those yet. It'd be an example would be like y equals x cubed minus 3x squared plus 2x plus 9. Degree of 4 is quartic. Think of like quarter. There's like 4 quarters. Oh, I wrote quarter as I said. Think of quarter. Quartic. And an example of that would be like y equals 2x to the fourth plus 3x cubed minus x squared plus 4x minus 8. The highest exponent we see is 4. And degree of 5, which is the last one we'll go over, would be a quintic. And so an example could be like y equals negative x to the fifth, plus 2x to the fourth minus 3x to the third plus 1/2 x squared, because you could have 1/2 as a coefficient, plus 4x plus 8. So we can have fractions and decimals for our coefficients, just not for our exponents. And then we talked about this a little bit earlier, but in a more standard note, a polynomial written in standard form, which is the form you always want to get it as, has all the terms written in descending order of the exponent. And we always want to put our answers in standard form. So if you notice, all the examples I just wrote all have it in descending form. So even the quintic, it goes 5, 4, 3, 2, 1, 0. A leading coefficient. Well, leading means it's in front. Coefficient's a number with a variable. So it's the coefficient in front of the largest exponent. Because we want to put the one with the highest exponent first for the variables. So that means the coefficient that would come first is the number with it. So now for these 4 examples, we're supposed to put it in standard form. So the descending order of the exponents. And then state the degree for the number, the type as far as like linear, quadratic, you name it, and what the leading coefficient is. So in letter A, f of x, so f of x is this. So 8x plus 5x to the fourth minus 3x squared minus x cubed plus 7. So you say, hey, what has the highest exponent? It's 5x to the fourth. And what has the next highest exponent? Well, it's negative x cubed. Next is negative 3x squared. Fourth is plus 8x. And last is plus 7. The degree, the highest degree, was 4, which makes the type, going back up to our little reference we made here, quartic. And the leading coefficient, the first number you see when it's in standard form, is 5. With that being said, go ahead and try letter B on your own. So on letter B here, the standard form, f of x, would end up being negative 3x cubed plus 0.25, or just 0.25, x squared plus 16. Because we see our exponents going from 3 to 2 to none. So the degree would be 3 because that's the highest exponent, which makes the type cubic from our table above. And the leading coefficient is negative 3 because that's the number with the exponent with the variable with the highest exponent. Try letter C and D on your own. On C, we'd say f of x is equal to negative 7x squared plus x minus 12, which makes the degree 2, the type a quadratic, and the leading coefficient negative 7. On D, the standard form would be f of x is equal to 8x plus 3. The degree is 1, because that's the highest exponent even though you can't see it. The type is linear, and the leading coefficient is 8. Alright, so on the next three we are asking, hey, which of the following are not polynomials? Excuse me, why are the following not polynomials? Excuse me, they're all not, but why are they not? Well, going back up to our definition above, the polynomial has many terms, and the exponents have to be positive integers, and the coefficients are real. So no imaginary coefficients, and exponents have to be positive integers, so no fractions, decimals, negatives, anything like that. So this first one, why is it not a polynomial? Well, you might have noticed already, that exponent's negative. So maybe you say, hey, it has a negative exponent. Go and see if you can figure out the next two. The second one, we'd say, well, it's not a polynomial because it has an imaginary number. And polynomials don't have imaginary numbers. On the third one, it's not a polynomial because it has a non-integer exponent, aka it has a decimal in the exponent, maybe something you said. So any of those things would make these not a polynomial. Alright, last but not least, breaking out fancy calculators here, or on the iPad we can use Calc84, or if you have a phone you could use the smartphone app for that. So graph each polynomial function on the calculator, identify the type of graph and the number of real zeros. As a hint, the number of real zeros is less than or equal to the degree. So before we even graph it, we can already identify the type of graph. So here it's already in standard form, so we know our degree is 4, because the highest exponent is 4, which means that the type is a quadratic. Now what we don't know yet is the number of zeros. So how we do that is we go over to our calculator and you hit the Y equals button on the TI-84. So I go to Calc84, the app, and I'm going to go to Y equals, which is up here, right where I'm kind of highlighting here above the green second button. And as you hit it, you can type in these functions. And how I got those functions is, well, I pulled them from the notes. And if you're having trouble typing them, keep in mind that you have to use the negative down by the enter button in order to put a negative sign there rather than a minus sign. That is a difference for the 2x to the fourth. Make sure that's negative. And then the exponents, underneath the clear button on the far right, you see that little caret, the up arrow, and that helps you get to an exponent. So now I turned the second graph off with the second equation because we're only focusing on the first one. And as we go to the graph, when we ask how many zeros does it have, how many real zeros, well, I mean, because there's actually could be some imaginary ones, weirdly enough, we say, how many times does it cross the axis, the x-axis, the left and right one? And we see it cross that axis twice. We see it cross once left of 0 and once right of 2. So we say, okay, sorry if you had that loud sound there. I'm going to try and skip the video. I do not want to get that. All right, so the number of zeros ended up being 2, number of real zeros. Letter B, I'd encourage you to try it on your own. On letter B, the degree is 5. The type is quintic because the degree is 5. And then the number of zeros, let's turn to our graph. Oopsie. Now you go back to y equals and toggle which one I have on or off. And I see it crossing and or touching the axis, x-axis, twice because it also touches right here as well as going through over here. So let me go back to zoom standard, so that way it's not all funky. And now we can see, hey, yeah, it has 2 x-intercepts, or 2 real zeros. So those would be our answers. And that is all for today for 6.1.